welcome back. Today we are going to solve this problem, online stock span. So we have a class which collects daily prices for some stocks and returns the span of that stock price for the current day. And the span of the stock is defined as the maximum number of consecutive days, starting from today and going backwards, for which the price is less than or equal to today's price. Okay, for example, here, starting at today 50, then because the definition is starting from today and it can be equal to today's price, then our count plus 1. So, and then we go to 80. 80 is at least equal to itself. So we have 80 and then it goes backwards. We find, okay, 50 is smaller than 80. So 1 plus 1 equals 2. And then that's the same for 80. 80 has itself and then it plus 2. And then let's go to the 70s. And the 70, it has this 1 and then it goes backwards. The first number it hits is 80 and 80 is not less than 70, so there is no consecutive. It is not consecutive here. Then the result, the span of 70 today is only 1, and then it goes to 90, and it still checks if 70, 80, 80, 50. Oh, they're all smaller than 90, so it's consecutive. Then the span of today is 5, so on and so forth. So we want to use a data structure that tells me, suppose we add today. We want to see what is the highest price of yesterday. And also, since this question says the maximum the increasing trend should be consecutive, then if we find any number that is bigger, it's not consecutive, then we will stop the trend at once. For example, here, at 70 we go back, and if we see 80, then we simply stop counting because it's not consecutive anymore. Return the result. So we are going to use a different stack to solve this problem. So at each point, we will, before we put this price into the stack, so here suppose this is the bottom of the stack. Before we push this price into a stack, we want to see what is the maximum number in the stack. So for example, here, at the beginning we only have 50. 50 is the stack is empty, then we simply push it to the stack, and then the span is 1. And then at the point of 80, we first compare if 80 is, we will compare our current with the top of the stack. Say here 80 is, so the top of the stack is 50. It is smaller than the 80. Then we say, okay, we find one element that is smaller than 80. Then we can accumulate the span plus. So now the span is 2 because 80 itself is equals to 80, so 1 plus 1 is 2. After that, we will pop out the element from the queue, and then we push our current element 80 into the queue, and then we get another 80, and now we are still going to check if the day price is if it is smaller or bigger than the top of the stack. So here we say 80 equals to 80, then we want to reuse the 80. We want to reuse the previous span, and so here the span would be 1 plus 2. Here 2 should be 2 is the span of the day on the top of the stack. So here actually we need to store two elements. It is the price and also the span of that count. So okay, after we get that, we can pop this element out of the stack and then push our current day, the price and the span. Okay, and then we go to the 70s. We say okay, 70 is smaller than the 80. So then we do not pop this out. We simply add this element to the stack, and then we go to the 8, go find the 90. So now we can see 90 is bigger than 70. So this means somewhere in the so we maintain an attribute of the stack, which is the price are increasing. So if the top of the stack, the price is 70, it is smaller than the 90, then that means somewhere in this stack the price can be 75 or 82 or 90, so we have to keep popping. So after we pop, we will store the span of 90. So it will be 1 plus, okay, we pop out the 7, the 7, t, and then we will continue comparing the top of the stack with our current price, and we say okay, 80 is still smaller than the 90, so then we also plus 3, and then okay, then the stack is something, there's nothing, we can return the span of 90, so this is 5. And after we get 5, we have to push the price and the span into the stack. So what this means is there are 5 consecutive numbers that are smaller than the price of 90. And then we continue to 75. And okay, 75 is smaller than 90, and since this stack is the price can only be increasing, so if there are elements further down in the stack, this can only be bigger than 90, so that is not what we are looking for. We are comparing it with 75. So then the span of 75 would be 1, and then so we okay, 75 is smaller, so we can safely push into the stack. So finally we have 85, and then we compare 85 is smaller than is bigger than 75, and we can draw to the conclusion the span of 85 is 1 plus this 75 here, 75, plus 1, yeah. And then, so the next step is compare the 85 with 90. It is not, then we stop. So span of 95 is 2, and then don't forget to push the 85 into the stack. So one important thing to remember is we maintain the stack, and the price in the stack can only be increasing, which is what this code can do. So let's simply review the code. Okay, so by definition, the span is at least 1 because starting from today's price is equal to today's price. So we have the result is at least 1, and we can only accumulate after it. And the stack we need to maintain the price increase property. So we always compare the price on the top of the stack with the current price. While the step is not empty, which means there are still elements in it, we are still going to keep comparing. And if the top of the stack, the price is smaller or equal to the current price, then we will add this, add the span of from the stack to our final result, and we keep doing the process until we get the empty stack or the peak, the element on the top, the price is bigger than our current price. And after that, since we maintain the structure of the span, since we want to remain the property of price increasing in the stack, then we will push the price and the span element back into the stack. So it's good for the next use, then finally return the result. And this is an interesting problem. That is all.